In this video, we will be looking at how to solve non-homogeneous linear ordinary differential equations. The general form of a non-homogeneous linear ordinary differential equation with constant coefficients is of the form y double dash plus ay dash plus by equal to r of x, where r of x is not equal to 0. If r of x is equal to 0, it is called a homogeneous differential equation, and you have already studied how to solve such equations. We will be looking at the case where the right hand side, that is the r of x, is not equal to 0. To be a bit more specific, we will be dealing with cases where this coefficients a and b are constants, that is, they are just real numbers. Now, the general solution of such an ordinary differential equation will be of the form yh plus yp. That is, it will have two parts, yh and yp. The sum of these two will be your general solution. Now, what are these yh and yp? YH is the solution of the corresponding homogeneous part, and yp is called a particular integral. Now, first we will look at how to find YH. To find YH, what you have to do is you have to look at the corresponding homogeneous equation. That is, consider the equation with the right hand side equal to 0. You have already studied how to solve such equations. You solve those equations, and suppose c1y1 plus c2y2 is the solution of this given differential equation 2. Then YH is c1y1 plus c2y2. So what is YH? YH is nothing but the solution of the corresponding homogeneous equation. That is, you just consider the right hand side to be equal to 0, solve that specific equation, you write it as YH. Now we look at the second part, yp. In this video, we will be mainly looking at how to find yp, or the particular integral. The method that we will be looking at here is called the method of undetermined coefficients. This method basically depends upon your r of x. This method is usually used in cases where your r of x is an exponential function. There are a lot of cases. One is it can be an exponential function of the form e raised to ax, maybe e raised to 2x, e raised to 3x, or something like that. Or it can be sine or cos. That is, r of x can be, say for example, sine 2x or cos 3x, anything like that. It can be a polynomial also. It can be x raised to 4 or x square plus x, etc. Or it can be combinations of these, for example, e raised to 2x into sine x. We will look at how to find yp in such cases. So we will be considering each different case specifically. The first case we will be considering when your right hand side is an exponential function. So consider the ordinary differential equation y double dash plus a into y dash plus by equal to r of x. The first case is, suppose if your r of x is k into e raised to alpha x. That is, suppose it is something like, say, 2 e raised to 5x. Then how to find yp? Now in such cases, the choice of yp, that is, we will first be looking at a trial solution. So the choice of yp will be c into e raised to alpha x, where c is an arbitrary constant. And then we will find yp dash and yp double dash, and we will substitute those things in this given equation. We will equate the left hand side and the right hand side to find capital C. And then we will write the general solution as yc plus yh plus yp. Now let's look at a problem. Okay, the problem here is y double dash plus 5 into y dash plus 6y equal to 2 e raised to minus x. Now, as I told you, the solution of such an equation has two parts. One is yh and one is yp. How to find YH is just take this right hand side to be equal to 0 and solve it. Suppose if right hand side is equal to 0, then how do you solve it? You have to first write the characteristic equation. That is, in place of y you write down 1, in place of y dash you write down m, in place of y double dash you write down m square. Then you will get the characteristic equation as m square plus 5m plus 6 is equal to 0. Now what are the roots of this characteristic equation? It is minus 2 and minus 3. So the general solution will be c1 e raised to minus 2x plus c2 e raised to minus 3x. So now you have found YH. Your YH is c1 e raised to minus 2x plus c2 e raised to minus 3x. You already know how to solve the homogeneous part, so I am not elaborating anymore. Now we will look at how to find YP. So here you look at what your right hand side is. R of x is equal to e raised to minus x. So your choice of YP should be c e raised to minus x. That is any constant multiple of e raised to minus x. Next thing is you find YP dash and YP double dash. You find its two derivatives. Then you have to substitute those values, that is yp dash and yp double dash in the given equation, and then equate both sides to left hand side and right hand side. So equate both sides of the equation to find your capital C. So that is what we are going to do. So your yp dash is minus c e raised to minus x, yp double dash is c e raised to minus x, given yp is c e raised to minus x. Now substitute those in the given equation. You will get it as, when I substitute, we are getting it like this: c raised to minus x minus 5 into c raised to minus x plus 6 c raised to minus x equal to 2 e raised to minus x. The actual equation was y double dash minus 5 into y dash plus 6y equal to 2 e raised to minus x. So we have substituted those corresponding values there. Now equating both sides of the equation, this left hand side turns out to be 2c e raised to minus x and right hand side turns out to be 2 e raised to minus x. So c, the value is 1. So what is your yp? Yp is c e raised to minus x. So the specific yp, that the answer we get here is yp equal to e raised to minus x. So as I told you earlier, the general solution is YH plus YP. YH we had already found it. It was c1 e raised to minus 2x plus c2 e raised to minus 3x. YP we found it now. It is e raised to minus x. So y is YH plus YP. This is how you have to find the solution. Now we will move on to the next case. That is, suppose now we look at the second case. It is the case when your right hand side r of x is a sine function or a cos function. That is, suppose if your r of x is sine 2x or say cos 4x, then how to find yp. So we are looking at equations of the form y double dash plus a into y dash plus b into y equal to r of x, where r of x is, say for example, k sine omega x or k cos omega x. In that case, the choice of your trial solution, that is choice of yp, should be a cos omega x plus b sine omega x. The next step is we are actually going to find yp dash, yp double dash. We are going to substitute in the given ordinary differential equation. We are going to equate the left hand side and the right hand side, and then we are going to find these constants a and b. We will look at it with the help of an example here. We look at the question, we look at this question here. The question is y double dash plus y equal to sine 2x. So the first thing is you have to find YH. YH is the solution of the corresponding homogeneous part. So you have to take the right hand side to be equal to 0. Okay. Now once you take the right hand side to be equal to 0, how to solve it? You have to write the characteristic equation. For writing the characteristic equation, you have to replace y with 1, y dash with m, and y double dash with m square. So your characteristic equation comes out to be m square plus 1 equal to 0, and the roots of the characteristic equation are m is equal to plus or minus I. So you are having complex conjugate roots. So if if the roots of the characteristic equation are alpha plus or minus I beta, then the solution will be e raised to alpha x into c1 cos beta x plus c2 sin beta x. Okay. In this case, alpha is equal to 0 and beta equal to 1. So you are having e raised to 0 x into c1 cos x plus c2 sin x. Since e raised to 0 x is 1, the solution is c1 cos x plus c2 sin x. Now we have found the solution of the corresponding homogeneous part, that is, we have found yh. Now we have to find the particular integral, that is yp. So since your right hand side is sine 2x, the choice of yp should be a cos 2x plus b sine 2x. Okay. Now even if suppose your right hand side was cos 2x, then also the choice of yp will be a cos 2x plus b sine 2x. I hope that is clear. Even if it is sine or cos, the choice of yp is the same. It is a cos omega x plus b sine omega x. Okay. Now next step is we have to find yp dash and yp double dash. Since your yp is a cos 2x plus b sine 2x, yp dash comes out to be minus 2a sine 2x plus 2b cos 2x, and yp double dash comes out to be minus 4a cos 2x minus 4b sine 2x. Now the next step is you have to substitute this yp and yp, that is yp dash, yp double dash, etc. in the given ordinary differential equation. So it actually becomes yp double dash plus yp equal to sine 2x. Now yp double dash is found here, yp is also found here. Now adding those, you get it as minus 3a cos 2x minus 3b sine 2x is equal to sine 2x. That is, equating both sides, you get minus 3 equal to 0 or a equal to 0. And that is, we are equating coefficients of cos 2x on both sides. Now we are equating coefficients of sine 2x on both sides. So you get minus 3b equal to 1 or b equal to minus 1 by 3. So your yp comes out to be minus 1 by 3 sine 2x. That is because your yp is a cos bx plus b sine bx, a cos omega x plus b cos sine omega x, and your a is 0, b is minus 1 by 3. So your yp is minus 1 by 3 sine 2x. Okay. So the general solution is yh plus yp. That is, the general solution is c1 cos 2x plus c2 sin 2x. That is, this is your yh. We have already found this. Plus yp. Yp is minus 1 by 3 sin 2x. This is your general solution of the given ordinary differential equation. Okay. I hope that is clear. Now we will move on to the next case. The next case is, suppose your right hand side is a combination of exponential function and cos. That is, if it is k e raised to ax into cos omega x, or suppose if it is k e raised to ax into sin omega x. Suppose if it is like this, then what to do? Okay, for example, it can be e raised to 2x into cos 4x, or maybe e raised to x into sin 2x, something like that. In that case, the choice of yp should be e raised to ax into a cos omega x plus b sin omega x. Here a and b are arbitrary constants. We have to find yp dash and yp double dash, substitute in the given equation, and then find capital A and b. Small letter a, omega and omega are available, will be available with us. Okay, so I'll illustrate that with the help of an example. Okay, you look at this question here. The question is d square plus 2d minus 3 operating on y is equal to e raised to x cos x. This is actually yp double dash plus y double dash plus 2y dash minus 3 equal to e raised to x into cos x. First, we will just find the corresponding yh, that is the solution of the corresponding homogeneous equation. So the corresponding homogeneous equation is nothing but you just take the right hand side to be equal to 0. And then you have to replace y with 1, y dash with m and y double dash with m square. So the characteristic equation becomes m square plus 2m plus minus 3 equal to 0. The roots of the characteristic equation are minus 3 and 1. Hence the solution will be c1 e raised to minus 3x plus c2 e raised to x. This is the solution of the corresponding homogeneous part, and that is your YH. Now we have to see how to find YP, the particular integral. Okay, to find the particular integral, since your r of x is e raised to x into cos x, the choice of YP should be e raised to x into a cos x plus b sin x. Remember, the general method is if your r of x is e raised to ax into cos omega x, then your YP should be e raised to ax into a cos omega x plus b sin omega x. Here small letter a is 1 and omega is 1. So your YP should be e raised to x into, you don't have to bother much about that. If your solution, if your r of x is e raised to x into cos omega x, your YP should be e raised to x into, instead of cos x, you take it as a cos x plus b sin x. Okay, now you find its two derivatives, yp dash and yp double dash. That has been done here. So yp dash, it comes out to be, first I am taking derivative of e raised to x, that is written here, then into second term. Okay, next what we are doing is we will be writing e raised to x into derivative of this term. That is what is written here. Now that in simplified form comes out to be e raised to x into a plus b times cos x plus b minus a times sin x. In similar terms, you will have to find yp double dash also. Yp double dash comes out to be e raised to x into 2b cos x minus 2a sin x. Now what you have to do is you have to substitute all these in the given ordinary differential equation. That is, your given ordinary differential equation is y double dash plus 2y dash minus 3y equal to e raised to x cos x. So instead of y, we are substituting yp. Instead of y dash, we are going to substitute yp dash, and instead of y double dash, we are going to substitute yp double dash. So yp double dash minus plus 2y dash minus 3y equal to e raised to x cos x. That is what is evaluated here. Now what you have to do is you equate both sides. That is, on the left hand side you have e raised to x into cos x. So all the coefficients of cos x, you take it together, that comes out to 4b minus a, and that you have to equate it as 1. It is 1 times e raised to x cos x. Now similarly, you take all terms involving sin x together. The coefficient of sin x, e raised to x into sin x, there is no term involving e raised to x into sin x, so it is 0. So you equate that coefficient of sin x as with 0. Now from these, solving these two equations simultaneously, you will get a as minus 1 by 17 and b as 4 by 17. So your yp, that is your particular integral in this case, is e raised to x. That is, remember your solution was e raised to x into a cos bx plus b sin bx. So your solution will come out like this: e raised to x into minus 1 by 17 cos x plus 4 by 17 sin x. Now combining your YH and YP, you will get the general solution. That is, the general solution is YH plus YP. YH is C1 e raised to minus 3x plus C2 e raised to x, and YP is e raised to x by 17 into 4 sin x minus cos x. I hope that is clear. Now we will move on to the next case. The next case is, suppose your right hand side is a polynomial. It can be something like kx raised to n, or any sums of terms like that, a polynomial like x square plus x, anything of that sort. In that case, what we have to do is, suppose if your right hand side is kx raised to n, then you have to, your choice of yp will be kn x raised to n plus kn minus 1 x raised to n minus 1 plus etc. k1 x plus k0. That is, if your right hand side is kx raised to n, you have to replace that with the expression of a general polynomial of degree n, okay, with all terms. So that it will be better if I illustrate with an example. Just for example, suppose if your right hand side is x raised to 4, then you have, your choice of yp should be k4 x raised to 4 plus k3 x cubed plus k2 x square plus k1 x plus k0. Okay, now we look at a problem here. Now in this given question, your given differential equation is y double dash minus 2y dash plus 5y equal to x square. So as usual, we will solve the corresponding homogeneous part. We will take the right hand side to be equal to 0. Your characteristic equation or auxiliary equation comes out to be m square minus 2m plus 5 equal to 0. The roots of the characteristic equation are m equal to 1 plus or minus 2y. So the general solution, that is the solution of the corresponding homogeneous part, will be e raised to x into c1 cos 2x plus c2 sin 2x. You should have studied how to solve the homogeneous differential equations by now. So this part is done. Now we have to move on to our part, that is we have to find yp. Now how to find yp? Your right hand side here is x square. So you should your choice of yp should be a general polynomial of degree 2. So a general polynomial of degree 2 will be something like this. It is k2x square plus k1x plus k0. So that should be a choice of yp. So yp dash, it is 2k2x plus k, yp double dash is 2k2. Now substitute all those in the given differential equation. The given differential equation is y double dash minus 2y dash plus 5y equal to x square. So substituting, you will get yp double dash minus 2yp dash plus 5yp equal to x square. That comes out like this. Okay. Now what you have to do is you have to equate coefficients on both sides. That is, here coefficient of x square is, remember the coefficient of x square is 1 here. So the coefficient of x square on the left hand side is 5k2. So equating those two, you will get 5k2 equal to 1 or k2 equal to 1 by 5. Now the next term, on the right hand side there is no term involving x. So the coefficient of x is 0. But on the left hand side, there is coefficient of x. The coefficient of x is 5k1 minus 4k2. So that you have to take it as your second equation. Okay. That you have to take it as your second equation. And then the third equation will be, you have to equate the constant terms on both sides. Then the constant term on the right hand side is again 0. The constant term on the left hand side is this 2k2 minus 2k1 plus 5k not equal to 0. Okay. Now you solve these three equations. So the first equation is 5k2 equal to 1, which I get by equating coefficients of x square on both sides. So that from there I get k2 equal to 1 by 5. The second equation is minus 4k2 plus 5k1 equal to 0, which I get by equating coefficient of x on both sides. And from there I get k1 equal to 4 by 25, since we have already found k2 as 1 by 5. Now the third equation is 4k2 minus 2k1 plus 5k0 equal to 0, which I get by equating the coefficients of, that is equating the constant terms on both sides. So from there I will be able to find k0, because we have found k1 and k2 already. Now you remember your that is your choice of yp was k2 x square plus k1 x plus k0. So substituting all those terms here, you get yp like this. This is your particular integral. Now we have to write the general solution as y equal to yh plus yp. That is, y will come out to be e raised to x into c1 cos 2x plus c2 sin 2x plus 1 by 5 x square plus 4 by 25 x minus 2 by 125. Okay. Now we have done. That is, from this is your yh, this is your yp. So taking the sum of both, you get the general solution. Now we have covered all the cases. Now next what we are going to look at a special case. That is, we are going to look at a note here. This is first I'll read that note. That is, if a term in your choice of yp happens to be a solution of the homogeneous ordinary differential equation, then multiply this term by x or by x square if the solution corresponds to a double root of the characteristic equation of the homogeneous ODE. Now this note I'll actually explain with some examples. So for example, in this given question, What is the right hand side you have? You have the right hand side as 2 e raised to minus x. Now suppose and your yh you are actually getting it as c1 e raised to minus 2x plus c2 e raised to minus 3x. Suppose if your right hand side here it was, suppose it was 2 e raised to say minus 2x. Suppose if that was your right hand side, then the problem is your right hand side is involving e raised to minus 2x, and in your yh also one solution is e raised to minus 2x. So here you will have a problem. If suppose your right hand side was not e raised to minus x, suppose if your right hand side was e raised to minus 2x, then the choice of yp will not be c e raised to minus 2x. The choice of yp will be c into x into e raised to minus 2x. The reason is e raised to minus 2x is already a solution, a part of your solution, that it is a solution of your homogeneous part. So when you take yp, you should take it as x into e raised to minus 2x, okay, because that has already been a part of your yh. That is what that note suggests. I'll repeat once again. In this same question, suppose instead of e raised to minus x, suppose you had e raised to minus 2x, okay, then what happens is you already have e raised to minus 2x in your yh. In that case, your choice of yp should not be c into e raised to minus 2x. It should be c into x into e raised to minus 2x. Okay. Now suppose if you had repeated roots here, suppose here your root was, say, the characteristic equation was, say, m plus 2 the whole square equal to 0. Then what will happen is you will have your solution yh as c1 into e raised to minus 2x plus c2 into x e raised to minus 2x. So your e raised to minus 2x is a double root of your yh, double root of your homogeneous equation, and it is also your r of x. So in that case, your yp should be x square into e raised to minus 2x. Okay, so that you should take care. So these things are there in the notes that are uploaded. So you just go through those problems and solve all those questions one by one. Thank you.